Hello everyone, I am Hari Prasad from Bannariam Institute of Technology. Today we are going to look into the subject 18AE403 aircraft propulsion. So today we are going to discuss the different types of aircraft fuel, the requirements of an aircraft fuel and how it can be effectively used in different kinds of aircrafts. Inside this particular combustion chamber, for the combustion to happen, so in the combustion chamber, we need three basic ingredients. One is the fuel, the next one is the oxygen, and third one is the ignition temperature. If we don't have any one of these component, it is very difficult for the combustion process to start. So now let us discuss about each one of these parameters and how they are available for a particular combustion which is happening inside a gas turbine engine. We will start with the oxygen. Since our aircraft flies within the atmosphere and our aircraft engines are air breathing engines, they take the air from the atmosphere. So are we going to use all the air that is going to be available for us? No. In the air we have lot of percentage of different sets of gases. For example, we have 78% of nitrogen, 21% of oxygen, and rest of the things are going to be composed of other gases. But in this particular air we are going to utilize only the oxygen which is going to present in there. So this oxygen is what going to help us to generate the flame or to produce the combustion within the combustion chamber. The next one is the ignition temperature. So how this particular ignition temperature is available? For example, the ignition temperature depends upon the fuel that we are going to use. First of all, this next one is it needs to be a sustained one. So for the combustion to happen inside the combustion chamber in a continuous way, we don't want the combustion to happen in an intermittent way. We want the combustion to happen in a continuous form. So for that we use flame holders to provide this ignition temperature for the fuel and air which is going to be present. We are going to discuss about these flame holders in detail in the next topic. Now we will concentrate on the fuels which we are going to use in our aircrafts alone. So the basic fuel that we use in our aircraft is called avgas, which is a short form of aviation gasoline. Some of the requirements of this particular gasoline is going to be, it should be easily available and low cost, and it should be low fire risk. Okay, this is because whenever a person is going to refill the aircraft and they are going to transport this particular fuel to a number of places, so this low fire risk is going to be an important factor. It has to have a high calorific value, which means a particular unit amount of fuel, when it burns, it needs to produce lot of energy. So calorific value is directly depends upon how much energy the fuel is going to carry for a unit volume. Then it has to be thermally stable, because this fuel has to operate at a wide range of temperatures. Then the specific heat is supposed to be high. So only when the specific heat is going to be high, we will get a high efficient combustion. Then it should be free from contaminants, because as far as the contaminants are there, it will affect the efficiency of the combustion process. Then it should have good atomization. So atomization in the sense, whenever the fuel is sprayed into the combustion chamber, this fuel has to be separated into tiny small droplets. So we will be discussing about this atomization in detail, how this particular atomization, what is the percentage of atomization that needs to happen in the future lectures. But you have to keep in mind that whenever we are going to atomize, that means whenever we are going to spray the fuel into the combustion chamber, it is going to produce much more efficient combustion rather than putting a coarse fuel particle into the combustion chamber. Then it should have a low carbon content. So this is required in order to make sure that our aircraft fly with a low pollution footprints. Okay, we don't want any carbon footprints. Since we are using gallons and gallons of fuel within a very short duration of time, we may have this particular fuel produce lot of pollution compared to other modes of transportation. So these are some of the basic requirements of our aviation fuel. Now let us talk about the different types of aviation gasoline that is going to be available. So this particular aviation gasoline is mainly depend upon the octane rating. So the types is going to be depend upon the octane rating alone. So before going into the different kinds of fuel, you must need to understand what is a octane rating. So the octane rating is generally the measure of resistance of gasoline and other fuels to detonation. So the detonation, in the sense, we have two images on the left as well as on the right. You see on the left hand side we have one flame front. That means the yellow color is actually in only one region. So this is actually the normal combustion, and this is what we expect inside a combustion chamber. So now we are discussing this with the help of the piston engines, not in the case of gas turbine engines, because the knocking capability is much more easy to understand with this particular normal combustion, these images. Okay, so on the right hand side we have premature combustion, which means whenever the compression is going to happen, so that compression so whenever the gases is getting compressed, the pressure is increased as well as the temperature of the gas is content is also going to be increased. So if the chamber is going to have, that means on the right hand side you can see that orange zone, which is the mixture of fuel and air. So that particular mixture of fuel and air, when it gets compressed by the piston engine, that compression itself is sufficient to ignite the fuel air mixture. So the ignition happens at lot of different points. So this phenomena is called knocking. So we don't want this kind of knocking phenomena to occur in a gas turbine engine or in a piston engine also. So this particular so the fuel which can resist this premature combustion is called which is going to carry a higher octane rating. So it is very simple. So we don't want the premature combustion inside the combustion chamber. Instead we need a normal combustion to happen. So whenever an fuel is going to have a low octane rating, then it definitely goes for a premature combustion. So we generally want a fuel which has higher octane rating. Okay, so this is what the resistance to knocking, okay, is generally provided with help of octane rating. So depending upon this particular octane rating, we can say three variants of aviation gasoline is most widely used in aircrafts. One is 100 LL grade. So again that 100 comes with the help of octane rating. The LL represents lead content. So how much lead the particular fuel is going to carry. So the 100 LL grade is going to look as a blue color due to the presence of lead in it. Whereas the next one is the green color one, which is 100/130 grade. So again it depends upon the octane rating, whether it is in the lean ratio or in the rich ratio. So on the 100 is actually the lean ratio, and the rating is 130 is actually the rich. Whenever we are going, the aircraft is going for a takeoff or landing, then it comes on the 130 grade. So that is going to appear as a green color. So these are used by different aircraft in aviation companies for their particular aircraft. Like each one of us is free to use our HP petrol or Bharat petroleum gas or Indian oil. So any kind of petrol we can use it for our particular vehicle, automobile vehicle. Similarly, the aircraft industry, depending upon the aviation, for example Indigo Airlines, or it can be Jet Airways, or it can be Air India. So depending upon the company, they will be choosing the particular fuel that they can use. Okay, but they will obviously produce different efficiency during the combustion process, and they give a different output. And finally, you look into the plain color, which is actually the jet propellant. So which we are going to discuss in detail in further. Okay, this jet propellant is mainly used for jet aircrafts. For example, this 100 LL and 100 bar 130 grade, these aviation fuels are used for commercial aircrafts alone. But these jet propellants are mainly based on, they are mainly used for jet aircraft, that means fighter aircrafts. So this jet propellant are JP I, that means the I varies from 1 to 10 depending upon the various amount of octane as well as the other contents which is going to be present in the fuel. But the major thing that you need to understand is, for example, the JP1 to 10, that means JP1, JP2, JP3. So of all these JP ratings, the more stable jet propellants are JP8 and JP4. So the JP8 is also widely called as a jet A fuel, and the JP4 is also widely called as a jet B fuel. So this jet B fuel has naphtha kerosene in it, which makes it much more difficult to freeze even at a very cold temperature, and at the cold regions it produces a better efficiency in its during the combustion process. That's why this jet B propellant is mainly preferred for the weather conditions where the for the cold weather conditions, and the jet A is preferred for our normal atmospheric conditions. So these are the different types of aircraft fuels that we use in our aircraft, and the requirements of the aircraft fuel. Thank you.